Hello and welcome to What the Heck Math. So today we're going to explore further the question, what the heck are derivatives? If you haven't seen the previous video about derivatives, I recommend that you go back and watch that one first. So today what we're going to do is basically I'm just going to go through some practice problems. I'll put a problem on the screen. Feel free to pause it to practice it yourself to see if you can solve it, and then you can return to the video and see if you got the right answer. So we'll be going over some different basic derivatives using the different rules that we went over in the past videos. That would be the power rule, the constant multiple rule, the product rule, the quotient rule, the sum difference rule. Okay, and we'll be using those to solve these derivatives. So we're no longer having to use the very long and complicated limit function, but we're going to use those rules instead. Okay, so let's go ahead and get started here. Okay, so our first problem we're going to solve is we're going to find the derivative of this function right here. So we're going to start pretty simple. Okay, so we're going to find y prime, or you can also say find dy dx. Remember, there's a bunch of different ways that you can refer to the derivative of a function. And using the sum and difference rule, we have a binomial, where we have two terms, and we can find the derivative of the whole function by finding the derivative of each term and then adding those derivatives together. So let's work with this one. Now, so we also have a minus in the front, so we can treat this as a minus 1 times x squared. So then it'll be like the constant multiple rule. So essentially what that means is whatever the derivative of this, there will be a minus there. Now, so whatever the derivative of this function is, there's going to be a negative in the front. And so now we can take the derivative, multiply that by x, derivative of x squared. And this is the power rule, so we're going to put the 2 in the front and then subtract 1 from that exponent. So that will give us 2 times x to the 1, or you don't have to write it. And we're going to add the derivative of 3. And then there's also basically the constant rule, which states that the derivative of a constant is always 0. So then our derivative of minus x squared plus 3 is minus 2x. Okay, let's try another one. Let's make it a little bit more complicated here. So let's move over to the middle. It'll be a little easier. Okay, so we got x cubed over 3. And let's add x squared over 2 and plus x. Okay. Now, so this one we have a polynomial again. We have 3 terms. So again, if we're going to find y prime, we're just going to take the derivative of each term, and there's addition, so we'll add them together because of the sum difference rule. Now, for these first 2 terms, we have something divided by something. So at first glance, it looks like you might want to use quotient rule. And you could use quotient rule. It would work here. But it's actually not necessary, because I can rewrite x cubed over 3. I'm going to come over here. I can rewrite that as 1/3 times x cubed. And this is just the constant. So now we're looking at the constant multiple rule. So then the multiple is going to remain, so I'm going to go ahead and write that down. So 1/3, oh, the constant is going to remain, sorry. And now I can take the derivative of x cubed, so I'm going to put the 3 in the front and then subtract 1 from the exponent. So we have 3x squared. Now, same thing for this one. I can rewrite that as 1/2 times x squared. And then when I take the derivative of it, because of the constant multiple rule, we'll have the 1/2 in the front. And then we'll multiply by the exponent and then subtract 1 from the exponent. So we got 2x. And now the derivative of x, we can look at that as x to the power of 1 and then use the power rule. So we'll move 1 to the front and then subtract 1 from the exponent. And then so we just get 1 times x to the 0. X to the 0 is 1 as well, so we get 1. And now we can do a little bit of simplification. So this 3 will cancel out with that one, and so we're left with just x squared. This 2 will cancel out with that one, and we're left with just x, and then plus 1. So there's the derivative of this function, x squared plus x plus 1. Okay, so now let's take this and this idea and let's do kind of a word problem with it. And I'm not gonna sit here and write the whole word problem up here because it would take too long and my handwriting isn't that great anyway. So what we're gonna do, let's look at this function. Here's a function. So x cubed minus 2x squared plus x plus 1. And what we want to do is, I should go ahead and write it. We're gonna find, find values of x for which this curve the curve meaning this function right here has horizontal tangents. Okay, so let's talk a bit about what a horizontal tangent is. Okay, so if I have a function that, let's say it looks something like this. Okay, each of these points here has some kind of a tangent line, and the slopes vary depending on where you put the point on the line. So we're looking for horizontal tangents. Horizontal meaning slope of 0. And so we're trying to figure out where along, now this function may not be this one, okay, it's just an example. But we're trying to figure out where along this curve are the tangents horizontal, or do the tangents have a slope of 0? And that's going to be, imagine that was a little higher, around there and there in this graph. Okay. So we're going to try and figure that out using just the function. We're not going to have a picture or nothing like that. Okay, so we're just going to figure out just using the function itself. Now, since we're looking for horizontal tangents, we're looking for tangents with a slope of 0. Well, given a function, if I want to rewrite this function in a way that it'll give me slope values, because right now this function for a given x value gives me a y value. But I want to get slope values of the slope of the tangent lines. Well, if you remember from the last video, slope of the tangent line equals derivative. So what that means is I'm going to take the derivative of this function. So let's go ahead and do that. So now it's a good rule of thumb, especially when you're studying this part of calculus. Pretty much every single problem you get that has a function, you're going to have to take the derivative of it. So it's a good place to start. So it's really helpful to get really good at it and practice it, because you're going to be doing it a lot. Okay, so let's go ahead and take the derivative of this function. So again, we have the sum difference rule. We have 4 terms here, so we're going to take the derivative of each individual term, and then we'll just combine them using addition and subtraction. So x cubed, we're going to move the 3 into the front and subtract 1 from the exponent, so that gives us 3x squared minus. Okay, now this is the constant multiple rule. So one thing you can do is you can say, all right, I want to move this 2 into the front. There's already a number there, so we're going to multiply those together. It gives us 4. And then subtract 1. So then we get 4x plus, now this is x to the 1. Move the 1 to the front, subtract 1, and we just get 1. And the derivative of a constant is 0. So we're not going to write that. So this is our derivative. Now, we need to figure out, where does this curve have horizontal tangents? So that means now that we have a function that gives us slopes, that's what y prime is, a slope of the tangent line, we want to figure out what x values does this function have a slope of 0, or what x values does this function equal 0. So we're going to set it equal to 0 and solve for x. Okay, let's try that. Now, when you do this, you could factor it if it's possible, and in this case it would be possible, but you can also just use the quadratic formula as well. This is going back to algebra. Okay, so now if I were to go ahead and solve this, and this is just a simple algebra 2 problem, probably solve this for x, I would get values of x equals 1 and 1/3. That's when this equals 0. So now I know that if at x equals 1 1/3 this function equals 0, well, that means at x equals 1 1/3 the slope of this function equals 0. Now that also reveals a little bit about how you can compare the graphs of a function and the graph of its derivative, and we'll look at that some other time. But it's just a really important idea to know, because a lot of times when you're solving, especially word problems using calculus, you're going to be finding the location of horizontal tangents. Okay, let's try another one. Let's see, let's start this one. Let's go a little bit higher exponents. So x to the 4th, and we're going to do minus 4x squared plus 1. So same problem, or same instructions as before. We're going to figure out where does this have horizontal tangents. So that means we're going to take the derivative. So this is going to be 4x cubed minus 8x to the 1st power plus 0. So there's our equation. There's our derivative. So we're going to set it equal to 0. So now first thing let's do, so we have an x in each term, so let's factor out, let's go ahead and factor out 4x. So we got 4x times x squared minus 2 equals 0. And so now we know, okay, we have two things multiplied by each other, so in order for this function to be 0, this will be 0, or this will be 0. So let's solve it for that first one. So we get, let's go ahead and create our terms here. We have, these are our x values that cause it to be equal to 0. Well, 4x equals 0, well, x is going to be 0. So now we can solve for this one. We can do difference of two squares here. We could also just move the 2 over, square root both sides, and we get plus or minus square root of 2. And there's a solution. Okay, so when x equals 0 and x equals plus or minus square root of 2, we get horizontal tangents. Okay, so let's try some problems that require the quotient rule. Okay, so this is going to be a little bit more complicated. Quotient rule is a little bit more difficult, but it's something that, you know, it's still possible. Okay, so let's start a little bit. Let's start a little bit simple. So let's do y equals 2x plus 5 divided by 3x minus 2, and we're going to figure out what is the derivative of this function. So now remember the quotient rule. If this function at the top is u and this function is v, it's going to be u prime v minus v prime u over v squared. Now, in the last video, I swapped these two. I put v u prime and then u v prime, but to me, u prime v minus v prime u, it just kind of rolls off the tongue easier. That's just my opinion. So, but it's up to you. Okay, but whatever you do, just make sure that the first function you take the derivative of is going to be the function that is in your numerator. Okay, that's very important, because if you do it backwards, then you're going to get the wrong answer. Simple as that. Okay, and the main reason you'll get the wrong answer is because you have subtraction. So you basically probably just end up getting the complete opposite of the right answer. Okay, so let's go ahead and do that. All right, so u prime, so the derivative of 2x plus 5 is 2, and then we're just going to copy v, subtract v prime, derivative of 3x minus 2 is 3, and then copy u, and then divide by v squared, so 3x minus 2 squared. Okay, so now let's do some simplification up top. Let's distribute. So we got 6x minus 4 minus 6x, and this is going to be 3 times 5, which is 15, but then we're going to have a minus, so it's going to be minus 15. And the denominator, well, let's just leave it. There's no reason to expand that. And now we can combine like terms. 6x minus 6x is 0, minus 4 minus 15 is minus 19. And there's our answer. So that's the derivative of this function using the quotient rule. Okay, so like I said, quotient rule, as long as you're careful, is not that difficult. Okay, let's try this one. This is not a quotient rule problem, but I think it's a good example of having to choose the better option. Because a lot of times these problems you have a choice depending on what you want to do as far as how you want to solve it. So there we go, and then we'll do a plus 1 again. Okay, so we're gonna take the derivative of this. Now, you totally could distribute. No problem with that. Okay. It would take a little bit of time, but as long as you multiply each term in one equation by every term in the other equation, you know, and then combine like terms, you'll get just a single polynomial that you can take the derivative of, and you'll get the right answer. You could also treat this as two functions of x multiplied by each other and use the product rule. So let's use the product rule. Okay, so we're going to do u prime, remember product rule, just a refresher, is u prime v plus v prime u. So u prime, that's going to be 3x squared plus 1 times v, x to the 4th plus x squared plus 1. Oh, I hope I have enough room. Let's go down here. Plus, okay, v prime, 4x cubed plus 2x times u, x cubed plus x plus 1. And so now actually we're going to have to expand if we want to simplify this out, but it's a little bit easier to expand because here we had 3 terms in each, and now we have 2 terms in 3 terms. So it's a little bit less work to expand it, but let's go ahead and try it out. Let's finish this problem. So we're gonna distribute that 3x squared amongst everything. So 3x squared plus times x to the 4th, so it's gonna be 3x to 6. Now we're gonna multiply by x squared, so plus 3x to the 4th times 1 plus 3x squared. Okay, now the 1 times everything, so basically we're just gonna copy that. Plus x to the 4th plus x squared plus 1. Oh, okay, and okay, let's add down here to the next one. So distribute the 4x cubed, so we get 4x to the 6 and plus 4x to the 4 plus 4x cubed. Now 2x plus 2x to the 4th plus 2x squared. Oh man, plus 2x. Okay. So let's go through and simplify. So we have 3x to the 6 and then 4x to the 6, so that's 7x to the 6. And we have 3x to the 4th. Now we have 4x to the 4th, 8x to the 4th, 10x to the 4th, plus 10x to the 4th. And let's see, any x cubes? Okay, we got a 4x to the cube, and it's only 1, so plus 4x to the cube, 4x cubed, not to the cubed. X squared, okay, 3x to the squared, now 4x to the squared, 6x to the squared. I keep saying to the, I don't need to say that anymore. 6x squared. Alright, power of 1. Let's see here. Just 2x. And then any constants, just the 1. So there's our derivative. Now if we would have multiplied these out and then taken the derivative of that, we would have gotten the same answer. Arguably might have been an easier method to go with, but a lot of times, you know, you have the choice to do it however you feel is best. Okay, so let's see if we can do something that's a little bit more complex. complex. Let's end on a yeah. Let's end on two more difficult problems. Okay. All right. So let's go with this one first. So we're gonna have x to the minus 4 over 4 minus x to the minus 3, and we're gonna go over 3 plus x to the minus 2 over 2 minus x to the minus 1 plus 3. So now we're going to take the derivative of this. Now here we kind of have an option as well. One option is arguably better than the other, but we still do have an option. And our option is how we're going to take the derivative of each of these terms that are fractions. And the main reason we have that option is because we have a negative exponent. Now this first one, and just like the rest of these, actually this one as well, you can rewrite x to the minus 4 over 4 as 1 over 4x to the 4. Okay. You can totally do that. Now the only problem is if you try to take the derivative this way, you'd have to use quotient rule, which in my opinion is something you want to avoid using if you can, because that v squared in the bottom could potentially just make your equation a little bit more complex than it needs to be. So we're not gonna, oh no, I just erased everything. Okay, let's go back. All right, just give me a second while I rewrite this. Let's try that again. Okay, so we don't want to move that x to the minus 4 to the bottom. So what we're going to do is we're going to treat this as a constant multiple rule. So I'm going to rewrite this. Make sure I click the right button. I'm going to rewrite this to be 1/4 times x to the minus 4. And I'll do the same thing for this one. 1/3 times x to the minus 3. 1/2 times x to the minus 2. Okay, so now it's the constant multiple rule. So now we can go ahead and start taking the derivative. So that 1/4 is going to stay. Now, just like the regular, even though we have a negative exponent, it doesn't change anything. We're still going to use the power rule, so we're going to move that to the front and then subtract 1 from the exponent. So that means we get minus 4x to the minus 5. And then here we have 1/3 comes back. Move it to the front, subtract 1, so we have minus 3x to the minus 4, plus, bring down to 1/2, move to the front, subtract 1, minus 2x to the minus 3, and then with our next term we got to come down here, we're going to move that to the front as well, so then we get minus x to the minus 2, and derivative of plus 3 is just 0. So now we can go through and do a little bit of simplification here. So we got y prime, so that 4 cancels there, but we still have that negative, so that gives us minus x to the minus 5. Then 3 cancel with that, we still got the negative, and this negative becomes positive, so we get plus x to the minus 4. 2 cancel with that, negative stays, we get minus x to the minus 3, and then we have that negative becomes positive, so plus x to the minus 2. Alright, so there's a derivative. Now the main thing that changed here is the fact that we had negative exponents this time instead of only positive exponents. However, it still works the same way. Okay, one more problem. This one's a little bit more complicated. So we're going to go square root of x minus 1 times the square root of, divided by the square root of x plus 1. Now, we have not yet taken the derivative of anything with the square root. Okay? So, what we need to do is see if we can rewrite these. This is what's causing the problem here, the square root of x here and square root of x there. So is there a way that we can rewrite this to make it so it looks like something we've done before? Well, how about let's rewrite square root of x as x to the power of 1/2, because those are equal. And do the same thing in the bottom. So now we have exponents. And guess what? Power rule works with rational exponents as well. It works the exact same way. Okay, so no matter what the exponent is, as long as it's a number, power rule works. Okay, so, but now this time we do have a situation where we have to use the quotient rule. So we're going to say u, that's v. So let's do this. Okay, so we're going to go, now remember, u prime v minus v prime u over v squared. So u prime, so we're going to take the derivative of this. So just like the power rule, put the 1, move that to the front, and then subtract 1. So then we get 1/2 x. Now 1/2 minus 1, minus 1/2. And the derivative of minus 1 is just 0. So now write v minus v prime. Well, it's going to basically be the same derivative as this. And then write u. And then we'll divide all that by v squared. Okay, so let's do some simplification here. This is going to be fun. Okay, so let's do that first term. So we're going to distribute this 1/2 x to the minus 1/2. Now, just for interest of saving space, when I multiply this by that, I'm going to end up having 1 over 2 times x to the 1/2 over x to the 1/2, because this x to the minus 1/2 just becomes part of the denominator. Those two cancel out to be 1, so then I just get 1/2. So that gives us 1/2. And then that's going to distribute across. Now I get plus 1 over 2, this is the square root of x. And I'm going to subtract. Oops, I'm running out of space here. Okay, do the same thing here. That basically cancels out with that, so then I get minus 1/2. And now I'm going to distribute that across. This is negative, so I'm going to get minus and minus, so it's going to be positive. So plus 1/2. Sorry, 1 over 2 square root of x. Let's just leave it like that. Okay. And right, so and then we gotta have all that divided by square root of x plus 1 squared. Simplify. 1/2 minus 1/2, that they cancel out. We add these two together and we just get 1 over square root of x all over square root of x plus 1 squared. Now that can be simplified by just writing this. You can move the square root of x here into the denominator. And here's the final answer. So that is our derivative of this function right here. So it just goes to show you that the power rule works with rational exponents too. If the exponent is 3/2, 2/3, 4/5, doesn't matter. Just do it the exact same way. Move the exponent to the front, subtract 1. As long as you always subtract 1, that's the kind of mistake that a lot of students use. They forget to do that, subtract 1. So as long as you always subtract 1, then you'll be okay. Also move the exponent to the front of the derivative as well. Alright, so I think that's good enough for today. So hopefully these problems were helpful for you. Keep an eye out for the next, we'll be doing a few more videos about derivatives, because there's a lot more functions that you can take the derivative of that require some more rules to learn, but we'll work on those later. Thanks for watching, and I'll see you next time.